For centuries, the English Channel served as a moat that kept the conflicts of continental Europe away from the island of Great Britain. While it served as a barrier for armies, it also served as a hindrance to commerce. The movement of goods and people across the English Channel was much more difficult than the small distance that had to be crossed. Some dreamed of one day taming that barrier, and in the 1990s, that dream came true. Learn more about the Channel Tunnel, aka the Chunnel, on this episode of Everything Everywhere Daily. This episode is sponsored by Planet Money. Tariffs, meme coins, Girl Scout cookies, what do they all have in common? Money. Economics is everywhere, and everything fueling our lives, even when we least expect it. If you're a fan of Everything Everywhere Daily and are curious to learn something new and exciting about economics every week, I recommend you listen to the Planet Money podcast from NPR. What I like about Planet Money is that I can get updates on the week's financial news in about 30 minutes. Stories like the Federal Reserve changing interest rates or the impact of trade policy. From the job market to the stock market to prices at the supermarket, Planet Money is here to help explain it all. The Planet Money hosts go to great lengths to help explain the economy. They've done things like shot a satellite into space, started a record label, made a comic book, and shorted the entire stock market. All to help you better understand the world around you. Tune in to Planet Money every week for entertaining stories and insights about how money shapes our world. Stories that can't be found anywhere else. Listen now to Planet Money from NPR. This episode is sponsored by newspapers.com. Break down genealogy brick walls with a subscription to the largest online newspaper archive. Did you know that newspapers.com has over 1 billion pages of digitized newspapers going back to the year 1690? Their growing collection includes papers from the United States, United Kingdom, Canada, Australia, and more. Discover birth and marriage announcements, obituaries, and everyday stories about your ancestors in seconds. Newspapers.com can help you fill in the gaps between vital records and reveal details about your ancestors' lives that you can't find anywhere else. Their easy-to-use search feature will let you filter your results by date, location, specific paper, and more. When you find something interesting, Newspapers.com makes it a snap to share it with your family and friends, and you can even save it directly to your ancestry tree. Come explore 1 billion pages and make infinite discoveries today on newspapers.com. Use promo code EverythingEverywhere for a 20% discount on your subscription. The origins of the Channel Tunnel goes back much further than most people realize. The English Channel is the narrow arm of the Atlantic Ocean that separates southern England from northern France, connecting the North Sea to the Atlantic. It's about 560 kilometers or 350 miles long and varies in width from 240 kilometers or 150 miles at its widest point to just 33 kilometers or 21 miles at the Straits of Dover, its narrowest point. Throughout history, the channel served as England's natural moat, offering critical protection from invasions. While it didn't make England invulnerable, it forced potential invaders to master both land and sea operations. Major historical examples include Julius Caesar crossing the Channel during the Roman expeditions of 55 and 54 BC. In 1066, William the Conqueror successfully crossed from Normandy during the Norman Conquest, which was one of the few successful invasions of England. During the Hundred Years' War, the Spanish Armada, and the Napoleonic Wars, the Channel played a decisive role in deterring or delaying invasions. In World War II, the Channel proved crucial to Britain's defense against Nazi Germany. Operation Sea Lion, Germany's planned invasion, was thwarted by Britain's naval dominance and the Channel's strategic buffer. And I'll refer you to my previous episode on Operation Sea Lion. While it wasn't very wide at its narrowest point, moving goods across the Channel was always more difficult than the distance would suggest. For hundreds of years, people have envisioned a way to cross the English Channel without having to travel by sea. The idea of connecting Britain and continental Europe dates back to at least 1802, when French mining engineer Albert Mathieu proposed a tunnel lit by oil lamps and accommodating horse-drawn carriages. While the idea was audacious, it was totally infeasible given the technology of the era. A walking tunnel under the Thames River wouldn't be finished until the year 1843, and that required a host of innovations. Given the length of the tunnel, oil lamps would have exhausted the oxygen deep in the tunnel without being able to replenish it due to the long distance to the opening. Throughout the 19th century, various schemes emerged, including bridges and tunnels, but they all faced technical, financial, and political obstacles. British concerns about invasion routes and French skepticism about British commitments repeatedly derailed early proposals. Interest in a channel tunnel ebbed and flowed throughout the 19th century, with significant momentum building in the 1870s. In 1875, Thomas de Guimond, a French engineer who spent decades studying the geology of the channel, joined forces with the Southeastern Railway in Britain to begin exploratory tunneling. By 1880, pilot tunnels had been excavated more than 1.5 miles under the seabed on both sides. However, British public opinion, fueled by concerns over national security, turned against the project. The fear of a French invasion via the tunnel led the British government to halt the project in 1882. Throughout the 20th century, the Channel Tunnel was repeatedly proposed and shelved due to wars, economic crises, and political caution. In the 1920s and 1930s, British and French rail companies periodically revived the idea, but nothing ever materialized. The concept came up periodically throughout the 20th century, gaining momentum after World War II as European integration became politically desirable. In 1957, the Suez Crisis highlighted Britain's need for stronger European ties, reinvigorating tunnel discussions. The Channel Tunnel Study Group, formed in 1958, conducted extensive feasibility studies and geological surveys. By the 1960s, serious planning resumed with both governments commissioning detailed studies. In 1973, Britain and France signed a treaty to proceed with construction, and work began in 1974. However, the project was cancelled in 1975 due to British financial concerns and cost overruns, despite significant progress in preliminary work. The current Channel Tunnel project began taking shape in the early 1980s. Prime Minister Margaret Thatcher and French President François Mitterrand agreed to invite private sector proposals for a fixed link in 1984. 4 competing schemes emerged, including bridges and tunnels. But the winner was the Channel Tunnel Group / France Manche Consortium, which won the contract in 1986. The construction of the Channel Tunnel represents one of the most complex underground engineering projects ever undertaken. The English Channel presented a unique geological opportunity, however. Beneath the seabed lies a layer of what's called chalk marl, a soft clay-like rock that is ideal for tunneling. This chalk marl layer sits between harder chalk above and clay below, creating what geologists call a geological sandwich. Think of it like trying to thread a needle through the filling of a layered cake while staying perfectly in the middle of that layer for 50 kilometers. The engineers had to maintain their boring path within this chalk marl layer, which varies in thickness from 25 to 45 meters. Stray too high and they'd hit water-bearing chalk that could flood the tunnel. Go too low and they'd encounter unstable clay that could cause cave-ins. The heart of the construction effort lay in the tunnel boring machines, or TBMs. And these weren't simply large drills. They were complete underground factories on wheels. The TBMs were massive cylindrical machines, 200 meters long and weighing 1,500 tons, roughly the equivalent of 150 elephants lined up end to end. At the front sat a circular cutting head, 8.78 meters or almost 29 feet in diameter, studded with cutting discs that rotated to scrape away the rock face. As the machine bore forward, it simultaneously built the tunnel behind it. The cutting head rotated at about 2.5 revolutions per minute, deliberately slow to maintain precision. The cutting discs, each weighing several hundred pounds, were positioned strategically to create an optimal cutting pattern. As they scraped against the chalk marl, they generated tremendous forces, requiring the entire machine to brace against the tunnel walls through gripper pads that extended hydraulically. Think of it like a massive mechanical earthworm that eats rock at the front and excretes a finished tunnel in the back. The cutting process produces what engineers call spoil, the excavated material that had to be continuously removed from the tunnel. Behind the cutting head lay perhaps the most ingenious part of the TBM, the segment erector. As the machine advanced, it left behind a gap that had to be immediately lined with concrete segments to prevent collapse. The segment erector, a robotic arm system, precisely positioned precast concrete segments in a specific pattern to form the tunnel's permanent lining. Each ring of the tunnel lining consists of 6 segments plus a keystone, fitted together like pieces of a three-dimensional puzzle. The segments were delivered to the TBM through the service tunnel in the middle and positioned with millimeter precision. Once a ring was complete, the TBM used it as a base to then proceed with the next excavation cycle. One of the most underappreciated aspects of tunnel construction is spoil removal. The TBM generated approximately 8 million cubic meters, or 882.5 million cubic feet of excavated material, enough to fill 3,200 Olympic swimming pools. The material had to be continuously transported away from the cutting face through narrow tunnels. The British side used a sophisticated conveyor belt system that carried spoil through the service tunnel to the surface, where it was used to create Samphire Hoe, a new 74-acre park. The French side employed rail cars running on temporary tracks. This logistics operation required precise coordination, because any delay in spoil removal would halt the entire boring operation. Perhaps the most remarkable engineering challenge was maintaining accurate direction over such vast distances. The British and French teams worked towards each other from opposite ends through solid rock with no direct communication. Yet they had to meet within centimeters of accuracy. This required revolutionary surveying techniques using laser guidance systems and gyroscopic compasses that could maintain accuracy despite magnetic interference from the TBMs. Survey teams were continuously taking measurements with every few meters and making minute corrections to the TBM's path. The surveying challenge becomes even more impressive when you consider that the tunnel follows a gentle curve rather than a straight line, descending from each side to a maximum depth of 75 meters below the seabed and then ascending to the opposite shore. The engineers had to account for the Earth's curvature, tidal effects, and even the gravitational pull of the sun and the moon. The moment when the British and French teams met in December of 1990 represented a triumph of precision engineering. After boring from opposite sides through 37 kilometers of seabed, the alignment error was only 358 millimeters horizontally and 58 millimeters vertically, less than the width of a standard doorway after traveling the distance from New York to Philadelphia underground. Throughout construction, water management remained a constant concern. The chalk marl layer, while relatively impermeable, still allowed some water seepage. The TBMs incorporated sophisticated pumping systems capable of handling thousands of liters of water per minute. More challenging were unexpected water inflows when the machines occasionally encountered fissures or more permeable rock. Engineers developed rapid response techniques using chemical grouts that could be injected to seal leaks within minutes, preventing potentially catastrophic flooding. The end result was 2 rail tunnels, one in each direction, and 1 central service tunnel. The mid-tunnel has a cross passage every 375 meters for safety and maintenance. In the event of an emergency, people could evacuate the tunnels via the middle service tunnel. The Channel Tunnel officially opened on May 6, 1994, with Queen Elizabeth II and President François Mitterrand presiding over the ceremony. The project cost approximately £10 billion, significantly over the original $5.5 billion estimate, and it took 6 years to complete. Eurostar passenger services began immediately, offering high-speed rail connections between Paris, London, and Brussels. Les shuttle, car, and freight services also commenced, allowing vehicles to be transported through the tunnel on specialized rail cars. The tunnel reduced journey times dramatically. Paris to London went from over 7 hours by traditional ferry and rail routes to just 3 hours by Eurostar. The tunnel faced several significant challenges in its early years. A significant fire in November of 1996 involving a heavy goods vehicle shuttle caused extensive damage and led to improved fire safety measures. Financial difficulties plagued the operating company, Eurotunnel, which struggled with massive debt from construction cost overruns. I had the pleasure of traveling on the Eurostar through the tunnel. On the London side, you board at the St. Pancras station, and from there you have direct service to Paris, Brussels, Rotterdam, and Amsterdam. And from many of those stations, you can get connecting trains all over Europe. It is more convenient than traveling by plane because you're in the middle of the city, but to be honest, it isn't that much cheaper. And boarding the train isn't like getting on a regular train in Europe. The process is closer to boarding a plane due to security. The Channel Tunnel transformed trade relationships between Britain and continental Europe, facilitating the easier movement of goods and people. Since its opening, it's carried over 400 million passengers and millions of vehicles. The tunnel has also had a profound cultural impact, making European travel more accessible and reinforcing Britain's physical connection to the continent despite its island status. And it's also one of the world's greatest engineering projects. It's the modern manifestation of a dream that was originally dreamt several centuries ago. The executive producer of Everything Everywhere Daily is Charles Daniel. The associate producers are Austin Oakton and Cameron Kiefer. I want to thank everyone who supports the show over on Patreon. Your support helps make this podcast possible. I'd also like to thank all the members of the Everything Everywhere community who are active on the Facebook group and the Discord server. If you'd like to join in the discussion, there are links to both in the show notes. And as always, if you leave a review or send me a boostagram, you too can have it read on the show.